If you've ever tried talking to a virtual assistant and walked away feeling completely frustrated, you are about to find out exactly why. Welcome to this explainer, where we're going to unravel the invisible, wildly complex rules of human conversation and figure out why it's so incredibly hard to teach these rules to machines. Seriously, think about it. Have you ever wondered why chatting with systems like Siri or ChatGPT sometimes feels clunky, stiff, or just a little bit off? For us humans, conversation is this high-speed, joint activity we just do effortlessly. It feels totally natural. But under the hood, human dialogue is governed by a dizzying array of invisible rules. And today, we're going to reverse engineer them. So let's dive into Section 1, the anatomy of conversation, how a chat is actually physically built. Before we can teach a machine to talk, we have to understand the basic construction. We build conversations in sequences called turns. It's like a game. You take a turn, then I take a turn, and so on. In a totally mundane chat, say between a travel agent and a client, we just effortlessly know when to start and stop talking. Imagine the agent is explaining something and the client suddenly interrupts with a question. A human agent instantly knows to stop, let the client correct course, and then pick the thread right back up. But a machine gets incredibly confused by this. This brings us to a massive headache for AI called endpointing. A system has to figure out when you're actually done speaking so it can process your words and reply. Sounds simple, right? Well, it's actually immensely challenging. We humans constantly pause right in the middle of our sentences just to think. That is exactly why your smart speaker rudely cuts you off while you're staring into the fridge trying to remember an ingredient. The poor machine literally can't tell the difference between a thoughtful pause and the actual end of your sentence. All right, Section 2, words as actions, because there is a real purpose behind the things we say. If we look past the physical back and forth, we hit this brilliant philosophical insight from thinkers like Wittgenstein and Austin. They realized that every single thing we utter is actually an action. When we speak, we aren't just tossing passive data into the air. We are performing a speech act. We're actively trying to do things to or for our listener. We're expressing our underlying intentions. Experts break these down into 4 major classes. First, we have consitives. That's when you state a fact or make a claim, like saying, I need to travel in May. Then you have directives. This is where you try to get the listener to do something, maybe asking a question or giving an order. Third are commissives, where you commit to a future action, like making a promise. And finally, acknowledgments, like apologizing, greeting, or saying thanks. So, when a travel agent asks, what day in May, they aren't just making a sound. They're issuing a directive. They're practically commanding you to answer. Moving on to Section 3, establishing common ground. Because conversation is definitely a team sport. Conversation isn't just throwing speech acts at each other. It's a deeply collective act. Think about an elevator button for a second. Why does it light up when you press it? It lights up to acknowledge it got your command. It grounds your action. Well, humans do the exact same thing. Both the speaker and the hearer have to constantly prove they understand each other. Otherwise, the whole conversation just falls apart. Researchers Clark and Schaffer actually mapped out how we ground each other, from the weakest signals to the strongest. It starts with just paying attention, then naturally moving to the next relevant point. Then we use explicit acknowledgments, stuff like nodding or tossing in an aha or a yeah. Moving up in strength, we use demonstrations, like paraphrasing what someone just said. And at the very top is a full display, where we repeat their words verbatim just to absolutely guarantee we nailed it. Section 4, detours and hidden meanings. Let's talk about the beautiful chaos of human thought. Because let's be real, we rarely speak in perfectly straight logical lines. In conversational design, control over the flow is called initiative. Primitive tech uses system initiative. That's where the machine rigidly asks a question and you're stuck until you answer it. But natural human dialogue, that's mixed initiative. Control shifts fluidly back and forth. I might ask you a question, and instead of answering, you ask me to clarify something totally different. We call these little detours subdialogues or side sequences. They completely interrupt the flow. Going back to our travel agent, say the agent asks about return flights on the 15th, and the client suddenly blurts out, actually, what day of the week is the 15th? Bam, complete detour. But a human agent effortlessly answers that side question, realizes the client wants to switch to a Sunday flight, and just smoothly steers right back to the main goal. And it gets even trickier when we look at hidden meanings. Imagine the agent asks, what day in May did you want to travel? And the client replies, I need to be there for a meeting that's from the 12th to the 15th. Did you catch that? The client totally failed to answer the direct question. They just brought up a meeting.
but the human agent understands it instantly, without skipping a beat.
So how do we do that? It all comes down to a theory called implicature, introduced by the philosopher Paul Grice. We make these massive inferences guided by common sense rules, like the maxim of relevance. Basically, we assume people aren't just spouting random nonsense. When the client mentions the meeting on the 12th, the agent's brain does this instant math. Okay, meeting's on the 12th. You gotta be in the city for it. People usually fly on the day before. Boom, they need a flight on the 11th. That is a massive leap in logic happening in milliseconds. It's completely unfair to expect a machine to just grasp that without some serious training.
Which brings us to Section 5. Teaching machines to chat. How do we tame all this conversational chaos?
How on earth do computer scientists translate this wild human behavior so an AI can actually participate? They use incredibly dense tagging systems. The MVP here is the Dialogue Act. It's a computational tag that captures the interactive function of a sentence. It beautifully wraps up what we've been talking about. It tags the speech act, meaning what the speaker is trying to do, and the grounding, meaning how they are confirming past information.
Depending on the job, developers create specialized rulebooks or tag sets. Imagine a tag set designed strictly for scheduling meetings. It'll have tags like suggest for proposing a date or deliberate for checking a calendar. But a system built for recommending restaurants, that needs totally different tags like requesting alternatives or confirming a price range. Different domains require entirely different computational rulebooks to function properly.
But what if you want an AI that can chat about, well, anything? That's where researchers bring in domain-independent systems, like the Damsel architecture. Damsel painstakingly tags every single utterance with two distinct functions. You have a forward-looking function, like making a statement or asking for info, and a backward-looking function, like agreeing with an idea, answering a prompt, or signaling that you understood.
And this right here is the ultimate payoff. Take that messy, perfectly human travel agent conversation we've been talking about and reverse engineer it into clean, computational data. Every single line gets tagged. One tiny utterance might be tagged as both an info request looking forward and an acknowledgement looking backward. By translating our chaotic human logic into these structured dialogue acts, an AI can finally begin to untangle the sheer depth of our interactions.
Which leaves us with a pretty big question. If a totally mundane chat about booking a flight is packed with this much invisible density, structure, hidden logic, and complex rule following, will a machine ever truly understand us? Or are they just forever destined to calculate our tags? Next time you have a simple chat with a friend, take a second to marvel at the effortless complexity of what your brain is doing. Thanks for joining me on this explainer, and I hope it completely changes how you view your very next conversation.